Hello and welcome to another Solana tutorial. Today we're gonna talk about token vesting. Ah yes, my voice is so nice and deep. That's because I have the Rona. Yeah, and I'm locked up in here for the next 10 days. And we're gonna do the same thing to tokens that the government does with me. We're gonna put them in quarantine. So, today I want to talk about token vesting, and we're gonna talk a little bit about what a crank is. So even if you're not interested in token vesting, you will learn something about Solana here in this video. Essentially, if you've never heard the term vesting, it's basically just locking away tokens. You might have heard the term a vesting schedule, because one of the main use cases for vesting is when you release a token that the person who gets it doesn't immediately have access to all of the tokens, but they're either just gradually released to them or after a holding period. And that's done to protect the price of the token in most cases, right? Because if you have bigger investors who get a lot of tokens, then they could, of course, crash the price if they sell all of it. That's why some projects use vesting schedules to only gradually release those tokens to the token holders. Yes, so that's the basic idea of vesting. And since I got quite a few requests to talk about that, and people want me to set up vesting for them, I have no idea how it's done. So that's what we're gonna learn today, how that's done. And we're gonna take the classic approach of I have no idea what I'm doing, but we're gonna find it out together. So let's get started. Welcome back to my YouTube channel. If we have a look at the SPL token documentation, at the very bottom of this page, we find token vesting. And it tells us there are two possibilities, either the Bonfida token vesting or the Streamflow time lock. And since I like the things that Bonfida developed, I'm just gonna go with that. I'm assuming that that's going to be pretty much the same thing, just a different program. The concept is the same, and that's what we're interested about. Also, we don't want to develop a smart contract / a program that does the token vesting. We just want to use one that already exists, like the one from Bonfida. So yeah, let's go check that out. There is also already a UI for that, but I'm actually more interested in a CLI, and that is available here. Okay, so if we have a look here, we can see that the program is deployed on Mainnet and on devnet, so we can play around on devnet and then do the same thing essentially on Mainnet just by providing a different address. The UI apparently only works on Mainnet, which is fine. We just need to know that if we want to test that out, we could actually start with that, get an overview. So we have a CLI tool, we have JavaScript binding, so either we can use the CLI or the JavaScript libraries. And then there's also a program that contains the source code of the actual smart contract. And this is a good illustration. Let's have a look at this. This is interesting because it illustrates how the token vesting actually works and who's involved with it. So we have the program, the token vesting contract, and we, as the person who wants to create such a vesting contract, can via the CLI or JavaScript bindings call the token program on chain. So we say, here are some tokens, I want them to be vested and available for that person at that time. So what we provide is the source, so where the tokens come from. Obviously we need to own them, so we need to sign for that. Then the destination, that's the public key of the address that receives the tokens once the vesting is over. Which token we're talking about, so the mint we need to specify, and we need to pay the fees, the 0.000005 for the transaction, or actually 0.00001 because we have two signers potentially if it's a different fee payer. And then we need to provide the schedule. So when, how many tokens are going to be released. And if that goes through, so if the vesting contract is successfully called, what we get back is the contract seed. That's basically, I guess, an identifier of that particular vesting contract. So that's the contract account that is created when I call this vesting contract. Then it creates this account. And in order for us to know which account that is, we need the contract seed. So by providing the seed, we know exactly which contract we're talking about. And we need to have that seed whenever we want to change anything on the contract. And I guess each of those accounts hold the following information: the destination address, the mint address, if it's been initialized, and then an array of schedules, which basically says at which slot how many tokens should be released. That's all stored in there, I guess. So what could we change if we are the receiver of the tokens? So essentially the guy who holds this public key, and we got the contract seed, so we know where the tokens are vested. We can, again with CLI JavaScript bindings, call another function of the smart contract to change some stuff. For instance, we can change to a different destination. For instance, I don't know, if my private key was compromised and I need to change to a different wallet, or I just don't want to use this wallet anymore, but I have a multi-sig wallet somewhere else now, or I move from one ledger to another one, or whatever the reason might be. Even while the tokens are vested, we can still change where they will be released to. But for that, we need to be the person who initially receives them. So if we are the current destination of the vesting, then with the current destination, and we can sign as them, then we can provide a new destination saying the remaining tokens should be released to this public key. And again, we need to sign for it. And then we can call the vesting contract again, and that will make the changes to the contract account. And then at the end of the vesting period, the tokens are released to the recipient. You don't see that. To the recipient. Look, it's hiding behind me. So essentially, the public key that was provided here or here, he will just get the tokens without having to do anything, without needing to know the contract seed, or without having to do anything, essentially. Except somebody has to do something, because on Solana or on blockchains in general, every state change goes through transactions. And that's why we will now have a discussion about what a crank is. We can only ever move tokens or sol or change anything on chain really when a transaction is broadcast to the Solana network. So somebody needs to create the transaction and push it through the RPC node to the validators. A program cannot by itself start executing something when a certain criteria is met. That's not how this works. A program only has functions that can be called, but the program itself doesn't run in the sense that a computer program runs, where it's continuously executing. No, it needs to wait for a transaction to arrive to interact with the program. And it can be called from a different program, but essentially somebody will have to have made a transaction and submitted it. And that's where this cranker comes in. This thing here is permissionless, which means anybody can do it. You only need to pay the transaction fees. That's all. But you can pay that from any address, but anybody can do that. And you need to know the contract seeds again. So we need to know which contract we were talking about. That's what we got back from the initial creation, the contract seeds. If we know those, then we can say, hey, I want to crank that. And what does cranking now mean? That's essentially an opportunity for the token vesting contract to send out the tokens to the receiver when the release slot has been reached. Because as I mentioned before, the program itself cannot simply start executing something. There needs to be a transaction. So we just need a cranker that provides this transaction, which says, here, have some execution time, have some compute units from me, and send those tokens out. That's essentially what the cranker says. And so the cranker can be myself, the one who created it. It can be the recipient if he knows the seed, or it can be any person. If anybody sees, hey, there's a vesting contract that still holds token even though the release slot is reached, anybody can just say, vesting contract, please release those tokens. By the way, also the Serum decentralized exchange works with those cranks to do the matching in the order book. Essentially, events are pushed on an event queue, and then you need crankers to actually execute those events. That's how Serum works. Or another example would be liquidations. Liquidations are such a thing. An on-chain program cannot liquidate because the on-chain program cannot start executing if some criteria is reached. That's why leverage trading on-chain also relies on such crankers, who are, by the way, rewarded for calling out such liquidations, such that somebody does it, right? And the program doesn't make the loss. And that essentially was one of the big problems. I don't know when exactly, but I think it was sometime back here when Solana was congested because so many people tried to liquidate, and then people couldn't, even put up more collateral, and we got a lot of liquidations because those crankers were just flooding the network because they wanted to get those liquidations. So that was a thing. Yeah, so that's what a cranker is. And we will also get to do that. I hope you already learned something today, even before we actually started playing around with the Bonfida token vesting. So do we want to start with the CLI right away, or do we want to have a look at the UI first? Maybe let's have a look at the UI, see how simple that is, and then do the same thing with CLI because it's probably more powerful. Vesti, because vesting is interesting. Vesting's interesting. Eminem. Pretty sure that's what he said. Okay, I have a Vesti address here. Now we need some Sol on that. Now we have some Sol and some tokens to vest. Let's try this. Okay. Things we can do here is unlock, change destination. But for that, we already need to have the contract seed. So it looks like we can't even create a new vesting schedule here in the UI. We need to go through CLI anyway. Cool, let's do that then. We will use this UI later. First, we play around with the CLI. How do we get access to that? Well, we gotta clone this thing. Git clone this thing. Token vesting. And by the way, this thing has been audited. That's why I trust this program. So in the CLI, let's have a look. You build the program, you deploy. Now I don't want to deploy. Creates a token, creates an account, mints some tokens, the classic that we always do. There, create. So you say which RPC, which program, then the function, create, which mint, which source owner, so that's the one holding the tokens, destination token address. Then that's the schedule, the amounts 2, 1, 3, add release times 1, and I think those are slots. So because the blockchain consists of, slots after slots, and then by providing a certain slot, you can essentially define the time of it being released. because they should come in a certain time interval, the slots. So the calculation of that is gonna probably be the toughest part on the whole thing. Yeah, and then we provide a payer, which can be the same or different to the source owner. It's probably usually the same. That's the create. And then we can also check it out, change the owner, and unlock it. Then there's linear vesting, which is with create. It's a bit more complicated. 42, release frequency, P1D, start time, end time. Okay, so that's for linear, from here to here in a linear fashion. You can release the tokens such that you don't need to do it in intervals. Like that would be this. And that would be just a linear release schedule. Yeah, which could be even more interesting actually. Okay, so let's get that CLI to work. I don't want to deploy it. Yeah, I can't do that on Windows. I also don't want to deploy the program. I just want to use the CLI. Build CLI, cargo build. There we go. That's easy. That's what we need to do. Yes, that's looking better. Because the program is already on devnet and on mainnet. We don't need to build that. Sometimes I'm really glad that I can do video editing. I have the impression that my poor computer is just overwhelmed with this. Look how slow it's writing. Like in the good old days with the typewriter. Now we get to the Solana stuff. Oh, the ED25519. We talked about that a few days ago. 2 more. 3 more. 2 more. Yeah, vesting contract CLI. Let's go build it. There you go. That took a while. Lol. And used 2 gigabytes of storage. What? Well, I hope that's worth it. Okay, let's check that in target debug we now have the vesting contract CLI exit. There we go, that looks good. We can provide flags, options, and a subcommand. So we have the change destination, create, info for printing, and unlock, that's the crank. Looks good. Looks good. Let's do an example on devnet first, just so we go through the entire token creation and everything again, because people still ask me questions about that. I've been talking about that for years now. Ow, oh, I shouldn't scream so much, my head. Okay, let's do it. We set our key pair to our vesting JSON that we created earlier. And then we go to devnet, and then we airdrop to Sol, and then we create a token. Well, first, because people still have problems with that, I'll also go through that one more time. If you want to create a token with a custom address, you first Solana keygen grind yourself the address you want. Starts with, I don't know, that's my token. There you go. That I want to have as my token address. And the important thing is, don't do anything with it. Don't put Sol there. Don't do anything. Just say SBL token, create token, maybe provide your decimals if you want something else than 9. I don't know, maybe I just want 6 decimals. Maybe I want it to allow freezing. I don't remember how that worked. Look it up in a different video. And then we just provide this address here. And that's it. And then we created the token with this address. Easy. Easy. Now we say SBL token create account for this token. And then we mint this token like, I don't know, 100,000. There we go. And now SBL token accounts should tell us that indeed we have 100,000 of this token. Okay, so far so good. Now, who do we want to send that to? Let's also make a account for that guy. So this is gonna be my receiver. And for that guy, we also need to create a token account. So SBL token create account this token. but for this owner, okay, I can't spell apparently. Create account. Yeah, and then this guy also has a token account, and the associated token account for this guy is this. We will need to remember this because we need to provide it in our vesting contract. So vesting, it's interesting. Let's get started with the actual vesting. So let's display help here one more time. Print this message. Let's display help of create. Oh yeah, that is very, very well formatted. Anyhow, okay, let's get through it anyway. We'll find our way. So amounts of tokens via vesting contract separated by commas. The sequence of inputs needs to end with an exclamation mark. Okay, so we release 1, then 2, then 3, and then we end with an exclamation mark. Okay, so far so good. That's just whether we want it confirmed or not. That's basically our commitment. So destination address. Specify the destination. That's a non-token account. Specify the vesting destination will be the associated token account for the mint of the contract. So we just need the public key. So not actually the token account, but just the public key of the address. And then the destination is the associated token account. Okay. Okay. Or we can, or alternatively, we can define the token account that we want to send it to. So define a destination token account address. This will be used instead of the destination then. So that will override the associated token account. Then end time. That's for linear vesting. The mint address, of course, the public key of the token. The payer, that's me who creates this. Defaults to client key pair. Okay. Release frequency. So that's for the normal release. If I specify the amounts, you can start on 1st of November and end of 5th with 1 day frequency. It will vest from total amount 5 times, split it linearly. Example, P1D. Internally, all data will be transformed into schedule. Or release times. Release times, unique timestamp to decide when the contract is unlocked. And again, with commas and then an exclamation. Can have a custom RPC. So specify the source owner. This may be the key pair file. Okay, defaults to client key pair as well. Source token address, specify the source token account address. Start date, first time of release in linear vesting. I'm still not sure what the P1D says. Repeat for duration of 1 day. Now, my question is, like, how many of those can I put in here? How many, what's the maximum? Because if the linear is just translated into that. Anyway, I think we're getting ahead of ourselves. Let's just first start and do a really simple vesting, like with the really, really simple. Let's do it. So we say create. First accounts. I need this. That's my token account. And I think I'm just gonna open this here because that's a bit more viewable. The URL reverts to the default. I don't think I need to provide this, but I will need to provide the program ID. Okay, so let's provide the program ID, which we can find up here. Nope, which we can find here. That's the one for devnet. That's the program ID. Then create. Maybe it needs to be in this order, maybe it doesn't. We'll just do it that way. Then the mint address, that's the token. Then the source owner that defaults to our key pair in the config, so we keep that. Then the source token address, that's gonna be this one. Then the destination token address. Now here I could put in the actual token address, or we just provide the destination address, which was this guy. And then amounts. Yeah, that's the question now. What do I put in here? I mean, that's still easy. I mean, let's say 10 at first, and then another 20. But now comes the hard part, the release times. release times in Unix timestamp to decide when the contract is unlockable. In Unix timestamps. Okay, that's actually not so hard. Unix timestamps are actually quite easy. Let's do 10, 20, 40, and then release times. The first one should have already been released, so after the first millisecond or second, and then we put in the current time, maybe let's say in 10 minutes. Yeah, let's do one in 9 minutes, let's do one in 30 minutes, and then an exclamation mark, there it is. Right, so those are my amounts, 10, 20, 40, already passed in 8 minutes, in 30 minutes. Anything else I need, the payer will also default to my default, and then, yeah, I could also say verbose to see a little more. And I think that's that. Let's just hit enter. Damn. Program ID which wasn't expected or isn't valid in this context. Did you mean program underscore ID? Yes, I did mean program underscore ID. Thank you for suggesting that. Error. The argument RPC URL wasn't found. Okay, so apparently we need to definitely define that. Okay, we can do that. Oh, it's just called URL. It's just called URL. Devnet. Boom. None value. Note, run with Rust backtrace1 environment variable to display a backtrace. Okay, fine. Then let's do it like they do on the documentation. Sweat, baby, sweat. Baby, CLI is a text that struck me, and you do the kind of stuff that only Prince would sing about. Can I even do that? I mean, echo, is that even a Windows command? That literally prints this. Congratulations. Sorry, I can't swear. Congratulations. That is useless. What am I doing wrong? I mean, I could have a look at that. The kind you clean up with the mop and bucket. 528. Subcommand create source key pair of okay. So apparently I do need to provide the source owner. Okay. See, reading the source really helps. Fine, let's do provide the source owner then. Provide the source owner, and then probably we also need the payer. Might as well, if we already provide it, put it here as well. Okay, but now. The seed of the contract is, there you go. That's what a seed looks like. Essentially just looks like an address to me. Please write it down as it's needed to interact with the contract. The vesting account pub key. So that's the public key of this thing. And with that seed, we can interact with it. Okay, cool. I think that's done. SPL token accounts. Let's see from our... Oh, of course, those amounts are specified in the lowest denomination. So that's not 10 tokens. That's 10 tokens by 6 decimals. So just, you know, if I had 0 decimals, then this would be 10. Yes. Anyhow, happens. So before it's time now, I do want to already crank it just for fun, which is basically done with unlock and then the seed and then whoever pays for it. So I keep the payer. I don't need anything else except the program and this stuff. And I say unlock. And I need to provide the seed, which I got here. So let's do that. That was quick. But did it do anything? I kind of want to have a look at this on chain. Okay, that account really just does nothing. Oh, wait. Step back. Not on mainnet, we're on devnet. So, okay. That looks better. So, at least here we have some bytes that we store stuff with. And Yep, we have the two transactions. That one where we created this thing. Yep, 0.00007 tokens. I put them into a vault, I guess, which is owned by that address, and that's the account. That is the account of the vesting contract, which is, owned by the vesting program. Okay, so far so good. Then the second transaction, that was the crank that I just did. What did that do? It cost me something, and it released the first 0.001. So that was the 10 that I wrote there. Nice. So now there are only 0.6 left. And if I do the same thing again now, because the time has already passed, if I do the same thing again now, put another crank, then refresh that. There we go. Then we got another 0.002 because that was the next in my vesting, the 20. And the 40 will not be released until in 20 minutes. So if I would crank it again now, now it even panics. So apparently there is nothing to crank, and then it tells me vesting contract has not yet reached release time, and then it stops. Okay, so at least I get an error if it's not successful, but I get nothing if it is successful, which is also, at least a transaction ID would be nice, right? People who develop this CLI, I would have at least liked the transaction ID as an output. Oh, I could have probably done verbose, which would have probably helped. Anyhow, so that's on me probably. Anyway, yeah, and that's essentially it, right? I mean, we can now also try out the thing with changing the owner. Ooh, let's do that. Let's put the info. Let's get the info. For that, I don't even need the payer because I don't put anything on chain. Let's just say info. And here it prints some information. Program ID. That's the seed that I also provided. That's the account pub key. That's the token account pub key. We saw that on chain already as well. It is initialized. That's the token, and that's the destination token address. So apparently, does it just store the destination token address and not even the actual account who has to own it? That's already empty, and here are 40 left. Release height, that's actually Unix timestamp. So it's not actually block. It's what I initially thought, but it's not. It's Unix timestamps, which, fair enough. There is a clock program that deals with that, I think. Yep, Syswar clock that can handle those sort of things. So we can work with actual time and not block depth, which makes it a lot easier. Yeah, what's next? I think that changing the owner is relatively trivial, and I'm gonna try it because why not? So let's grind ourselves another receiver, call it R2. What we then need to do is just say change destination with the seed, current destination owner, change destination. Let's check the help. And the same thing with new destination address or new destination token address. Choose one of the two. Then I can have a different payer, which just makes it more expensive because I have to have another signer. But we're going to do that anyway to try. So what we need is the seed. So the URL and the program ID again. Then the seed, the payer. And this one can be the same as we had earlier. Then the current destination owner. This needs to be the receiver wallet, new destination address. This is the new receiver, the R2. And this time we do verbose for more info. String is wrong size. Oh, right, because I don't need to provide for the new destination, I don't need to provide a key pair. Obviously, I just provide the public key. Boom. There we go. How verbose. How freaking verbose. Thank you so much. Anyhow, let's go on chain again to check this out. What we just did a few seconds ago. Here we paid double the fees because we had 2 signers. For one, this guy, and secondly, this guy. They both had to sign. That's why I have twice the 0.000005 transaction fee, which is okay on devnet. You know, I'm rich. Yeah, right. Because transaction fees are so expensive on Solana. Sarcasm, sarcasm, sarcasm. In case that wasn't obvious. And what happened here? Essentially, it just wrote something different onto the account. So onto this thing with the data. If we now go info again, then we see that this has changed, the destination token address, because our receiver is now a different one. And we can still get out those 40. In 10 minutes, we can get out those, and they will land on this token address. And that's actually going to be interesting to find out, because I never created this. This doesn't exist yet. This is not a thing yet. I didn't create this account. There's nothing there. It's not claimed by the system program or by the token program. So it's not a token account yet. It's just been used in a transaction. There the question is, if I release it, who then pays for that token account? Probably the cranker. Or it fails because the token account doesn't exist yet. And that's what I want to find out. But for that, we need to, wait another 9 minutes, 8 minutes. Yeah, I'll see you in 8 minutes. I'll be back. Right, welcome back. So we are going to attempt to unlock again, and it will fail because vesting contract has not reached release time yet. But in a few seconds, it will, and then we might potentially get another error. A few seconds ago, there we go. Now, no, still same error. Vesting contract has not reached time. Well, one more time. That's different now. Solana wasn't ready yet. Invalid account data. Token program said invalid account data for instruction. There we have it. So as I expected, because the associated token account for the second receiver doesn't exist, this will fail. So in case you ever encounter this, that's why. So in order to fix this, we need to say SBL token create account, SBL token create account from this token for the receiver, which is the R2 guy. Boom. I really can't type. Over there. There we go. That's better. There. And that's the 5.3s that we also saw in the info. Now it's actually being created. So if we now look at it on chain, if we refresh that, then boom, it has now become a token account. Very good, very good. And that then also means that if I now unlock, then it should go through. And I also don't get a freaking transaction ID or anything. Not a fan of this CLI, but can't have everything. And if we refresh it again, then we see that's the 40 that I specified. The 40 of those tokens I received here from this token account from the vesting contract. And yeah, that's essentially it. Now I still have a few more questions. First of all, how many of those unlock things can I provide? And secondly, how does the linear vesting work? Maybe let's start with secondly, linear vesting. That works pretty much the same way, except that you only specify one amount and then you specify the release frequency like once a day, and then you specify from which day to which day, which, all sounds reasonable. For our example, once per day is going to be boring. So, because I'm impatient, AF. So we're going to do the same thing again with the create. Just that this time we will not provide release times and we will only provide one amount, like 100 tokens, but this time actually with the correct decimals, and I had 6 decimals, so 1, 2, 3, 4, 5, 6. That's gonna be 100 tokens now. Destination address can be the same, source address can be the same, token will be the same. Okay, what is different now is the release frequency. Now I'm not entirely sure what I can provide here. Let's try. No idea if that works, but every minute. And then we have a start time. So it's 2022, 3, 19, 15, 50. So that should be in 3 minutes. And then a end date time with the same format. So I have 100 tokens. So 100 minutes. Let's calculate with 100 minutes. Let's just try this. Nope, we effed something up. Verbose was provided more than once. Okay. I'm gonna be super verbose. Panicked! Oh, I forgot something again. Oh, is this the same thing? Did I copy? Yeah. The same problem that I had before because I copied the wrong command. That's my bad. I need to provide the source owner and the payer. There you go. Boom. No. Okay, it doesn't like that. I don't know what I can put in here then. P1M? Okay. What? Frequency of release amount. Duration must be duration format. Well, that's certainly something that we can Google. T is the time that precedes the time component. Okay, because we have a minute and a month, which are both M, so we need to precede this one with a T. I mean, I'm pretty sure that the format is valid, and we put it here in single quotes. That's also okay. Just for the fun of it, would 1 hour work? Would, as you had it, 1 freaking day work? No. So apparently we messed up something completely here. Maybe we do not need those. 516. That's the start date. So maybe it does not like those. Just remove them. Fair enough. That better, sir? Panicked attempt to subtract with overflow amounts. Okay, so now we have calculation issues. So maybe let's go back to 1 minute. Makes the whole thing easier, I think. We're getting there. Ha. Oh, my head. We are getting to the source of this. If we have 100 minutes, because we are already answering the first question now that I had, we're answering both of them. If we have 100 entries for the linear vesting, then apparently it's just too much. Yeah, the transaction is too big to provide the data. It's not even that the account wouldn't be able to store that much, although it probably wouldn't. But it's that the transaction is too big. Okay, so let's, instead of doing 100 minutes, let's just do 50. Is the transaction still too big then? Still too big, but it's getting smaller as compared to before. Let's do just 16 to 1630. And then we also just do not 100, but 30 tokens to make the calculation simpler. There you go, that works. So let's check out this contract. So by the way, it costs us 0.0067 Sol to create such a vesting contract. So such an account. 0.002 for the token account and 0.046 for the actual this one contract account. Yeah, 30 tokens. This time it's actually 30 tokens. I put the decimals correctly. That's the instruction data, which, you know, is quite a bit of data. So no wonder that the transaction might have been too big. In any case, we can now get the info for this one by providing the seed. And there we see the 30 schedules. Every time you get one token, this time, at this time, at this time. So essentially, linear vesting is also just the step vesting, just that it's internally computed to do that, because that's how it internally works on chain. The on-chain program doesn't actually really do it linearly, which I would have found nice. And 30 seems to be okay. 50 wasn't, so somewhere in that ballpark. So I'm not 100% sure how many of those release intervals we can actually do. I mean, again, that would also be quite easy to find out, right? But first, let's unlock. But for the unlock, I need a payer. This guy, for instance, that's the only one that has Sol on the account, so I'm just going to use this one. But anyone can do that, right? So that worked. Immediately after, we can't do it again. We could. So the next minute has passed. But now if we do it, oh, interesting. I just learned something. Apparently, it will do it schedule per schedule. Or no? No. Actually, no. This one just failed. Invalid program argument. But the output here is like, there's no output and the transaction failed. I mean, this... Not happy with the CLI, must admit, but you know, you take what you get. Here, yeah, okay, it did release all the tokens that are ready to be. I thought it would do that schedule per schedule, which would have been stupid. Yeah, looks good to me. And if I refresh here, another minute passed, then I get another token. How nice. Okay. So far, so good. One last thing that I want to try before going on mainnet with this is how much can you actually do? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That would be my next question. Can the release times be not sequentially? So in other words, can I put in the same thing here? So that seems to work. Okay. So 30 seems to be okay. Let's do 10 more. Still works. 10 more. That doesn't work anymore because the transaction is getting too large. Okay, so 40 is still okay. 45 is not. Now the important question, is 42 still okay? As we learned in the Hitchhiker's Guide to the Galaxy, 42 is the answer. Which, unfortunately, it is not. 42 is barely too much. 41 could be the answer. Nope, 40 is the answer. Yeah, 40 is the answer. So I can do a maximum of 40 schedules, 40 releases. At least according to my experimentation. Which is what counts. Ooh, burn. That's a nice pub key. Yeah, I think we played around with vesting on devnet enough now. On mainnet, it's the exact same thing, just that you provide a different program ID here and a different URL here, and that's literally it. I can demonstrate that to you if you really want to. We have the 360 of my loop tokens that I sent myself earlier. And if we want to now do a vesting thing, we want to lock the 360 tokens away until 1720. So those are is my release time. I will just have one release time and I will vest the entire 360. And now we can try another thing here actually. I wanna have the destination myself, because why not? Why not put it to myself? I just want to lock away the tokens from myself. There could be another use case. I just want to keep myself from accidentally selling my tokens or sending them away, FOMOing, whatever. If you want to protect your tokens from yourself, that's how you do it. So I provide the destination address, the source token address is this one, then the mint is this one, that's that. The program ID, that's this one for mainnet. And then of course here we have to say mainnet beta as well. And then boom, we send it. Here we go. We have this as our seed. That's something that we need to remember because otherwise we won't get them tokens out. I still see the 3.6. I don't believe that. Oh, I made the same mistake again. Yeah, the 360. The 360, of course, without decimals, you stupid idiot. Yeah, but you get the point still. You get the... yeah. Beginner mistake. Once again, I did not account for decimals. Anyhow, we want to get those back now. Could put in our seed here and then put a different receiver here. We could do that. Submit. Transaction might fail. I mean, might. Let's see what actually happens. Transaction sent. Didn't make it on chain. Well, okay, so what we learned here is that this UI is absolutely useless. Absolutely useless. I mean, you can't change the destination and you cannot unlock. I don't see anything that, so I don't see how this UI is in any way, shape or form helpful. I don't know. I just don't know. So we will have to fall back to the CLI to unlock our tokens. Unlock with the seed that we have here. And that seems to have gone through. And if we now refresh here, then we should have all our 360 back, because here we got the 3.6 Ether -7 because 9 decimals, 360. Yep. So it works also on mainnet, and it works that we put ourselves as the recipient. It doesn't need to be another receiver. So yeah, I would say we learned something today. I think I'm gonna leave it here. This video is long enough, but since I already saw earlier how much amazing shit people send me, gotta look through that. I got some mint tokens. See, the problem with that is I don't go to mint, so scam token, please ignore. Ooh, and actually lots of tokens that are just unknown. I mean, I take them. I take all of that, because even if it's useless, if you create a token account for me, I can at least get that money out. Except I won't, because it's too much effort. That's a ledger account. To the more interesting things. Let's see if we have new NFTs. Rocket Mr. Bull on NFT. Promising 100x. Well, 100x from 0 is still 0. Yep, and I paid 0 for that, so I'm good with that. I mean, the 100x, I got a pass to some things. 14? I got 14 passes. Whitelist token for Cyberbulls. I only mint if it's a free mint. And if it's a free mint, you might as well send me the NFT. I'm not interested in your whitelist. Doobie-doobie-dip-dip-dip. I don't like the whitelist grind. Ed! I'm looking over there, not over there. Sure, Ed. Sure. I like the description. It says nothing. I love it. I get a lot of those. So I think that's all like whitelist tokens or some shit. I don't know. Yeah, whitelist. Don't send me whitelist tokens. Send me actual NFTs. God damn it. No, also take your whitelist tokens. But then send me your NFTs as well. Because I'm not going to mint myself. Freaking effort. Especially not with that wallet. VIP club member. Exclusive invitation. I think I'm getting a lot of spam now. Oh, look, is that another whitelist? Oh, look, more spam. Oh, my head. This one is new. The priest chain. Coolest priests on the Solana blockchain. Yes, yes, definitely. As cool as priests get. The much needed faith. Well, thank you guys for sending me your NFTs and whitelist tokens that I will not use. I hope that you learned something today about token vesting. Vesting is interesting. I'm now gonna go back to rest, and you can start to vest your tokens with the Bonfida vesting program. I'm afraid that I wasn't as funny as I usually am. I blame the virus. And I will see you in the next video. Until then, you can go check out those other videos and subscribe to my other channel. And yeah, like this video, join the Discord, and send me your NFTs, not your whitelist tokens. And then I will see you in the next video. Till then, bye bye. 'Cause it's the best thing. Vesting is interesting.